Hi everyone. In today's lesson we're going to be taking a look at what the graph of a basic square root function looks like. So in your notebook, please put today's subtitle, which is Basic Square Root Function. The most basic square root function has the following format. Y is equal to the square root of x. And this is the basic format because, as with any other graph, it is not being transformed by any other variables. Now, as with any new graph that you encounter, we're going to first look at what the table of values looks like before we graph it. So I would like you to prepare a table of values that has the following size. Go ahead, pause the video and do it now. Alright, so let's see what kind of coordinates we obtain for some random values of x. Now, to make our life easier, we're going to pick some perfect square numbers for the x values so that we don't go too much into the decimals. So I'm going to start at 0. The next perfect square is 1. After that would be 4. After that is 9. And I think that's as far as we need to go. Now when we plug each one into the basic function y equals square root of x, we get when x is 0, y is 0. When x is 1, square root of 1 is 1. When x is 4, square root of 4 is 2. And when x is 9, the square root of 9 is 3. Now before we graph this table of values, I have two very interesting questions to ask you. And you don't need to copy any of this down in your notebook. I just want you to listen for a moment. My first question is the following. Why did we not insert any negative x value, such as -1, let's say, -4, -9? Good for you if you remember that you can never have the square root of a negative number in the real number universe. So the square root of -1, -4, and -9 do not have any valid answers. So, scratch that. Now my next question is a more interesting one. How come we don't consider the negative versions of each of the x values when we square root them? For example, how come for x equals 9, we don't consider that the y value could equal to -3? Because after all, -3 all squared gives back our positive 9. Well, good for you if you realize that if we accepted both the positive and negative versions of the same x value, it would make our graph not a function anymore. Why is it not a function anymore? Because for a single x, you have more than one y. So, we scratch that idea also. And so, this is why we have this table of values, nice and simple. All the x values have to be positive, and for the y values, we do not consider the negative versions of the responses from square rooting the x values. Now, to accommodate the coordinates in front of us, you will need a grid that's about this size. So go ahead, pause the video now and prepare your grid. Alright, let's get our coordinates down. As usual for my graphs, I'm going to be using another color. So first let's put down 0, 0. Next, 1 and 1. Next, 4 and 2. And finally, 9 and 3. And then finally, if you can take a moment to connect all those coordinates with a nice, decent curve, you'll see that it kind of looks like half of a parabola, but on its side. Hopefully you can do a better job than I can of drawing this graph. And that's all there is, ladies and gentlemen, to how the graph of a basic square root function looks like.